So at this point in general chemistry, you might have noticed that a lot of the compounds you guys look at have the same generic general formula, AXN, where you have 1 of the first element and n number of the second element. And if that's the case, there's a really simple method of figuring out the Lewis structure. And usually it's easier than starting with just the Lewis symbols. Take, for example, a nitrogen trifluoride, which does have that general formula. So first thing we want to do is count up the number of valence electrons. And remember, using the grouping system that we use, the AB system where the main groups have are the A groups, whatever group number it's in for the main group elements, that's how many valence electrons it has. So nitrogen is in group 5. It has 5 valence electrons. I'm on fire. Fluorine's a halogen in group 7. It has 7 valence electrons for each one. So that all adds up to 26 electrons that we have to show as either lone pairs or bonds. All right, next thing you want to do is hook all the atoms together. And if it has the general formula AXN, we assume that the first element is our central atom, our A, and the X's are outer atoms that are bonded to A. Hey, I got him. So, so you always hook the X's to always hook your outer atoms up to your central atom. Don't hook them up to each other. So we're going to hook those 3 fluorines up to our nitrogen, and we're assuming they're at least sharing with a single bond, because that's how things usually work. You can have bond orders of less than 1, but they don't happen a lot, and usually don't see them at all in Gen Chem. So just hooking those 3 fluorines up to our, there it is. Oh, sorry. Hooking those 3 fluorines up to our nitrogen, that uses up 6 of our 26. The way we use up the remaining electrons is we start adding them as lone pairs, starting with the outer atoms. Was he there? Oh. No. Yeah, I tried to shoot my own guy. I suck. So anyway, we start adding lone pairs around our fluorines. And if you count it correctly, you should have enough to give your outer atoms their octets. It's the central atom that's usually in question. Have we got it yet? No. So giving all the fluorines their octets, which at this point means 3 lone pairs apiece, we still have 2 left. So those other 2 we'll put on the central atom. I got shot. This is a lot tougher than I thought it would be. I mean, I suck at Battlefield usually, but it's even tougher to do it teaching. But anyway, at this point, we've used up all our valence electrons, and also everybody has 8 valence electrons. Everyone has their octets, so everyone should be happy. So at this point, we're done. And really, for that compound, you probably could have started with Lewis symbols and come up with a structure pretty quick. But that doesn't happen a lot of the times. For polyatomic ions, for example, starting with Lewis symbols doesn't really work. For example, take nitrate. Nitrate fits our general formula, so we should be able to figure out its structure just like we did. Yeah, I'll do it. Just like we did with NF3 a second ago. Again, we start with our valence count. And again, nitrogen is in group 5. It has 5 valence electrons. Oxygen's in group 6, so 6 apiece. In this case, we also it's also a polyatomic ion with a -1 charge, which means that molecule's picked up an electron somewhere, and we have to add that electron to our valence count. So at that point, we have a total of 24 electrons that we need to show. And I'll do the objection. So again, next we start hooking everybody together, starting with single bonds, because if they're sharing, they're probably sharing single bonds. Hey, dude. Got me. Strafe. So hooking everyone together, again, we've used up 6 of our 24 electrons. Next, we start adding the rest as lone pairs, starting with the outside. No medics. There's never a medic when you need one. And I'm not playing as a medic right now. It's hard enough just running and gunning. But anyway, again, if you count it correctly, you should have enough to give your outer atoms their octets. And we do here. But don't get too crazy with the lone pairs. At this point, we've used up all of our valence electrons. Right. We don't have enough to give nitrogen 8. At this point, nitrogen only has 6. And some of you might remember nitrogen has nitrogen has a lone pair in its Lewis symbol, but there isn't a lone pair in nitrate. That lone pair went somewhere. We don't know where at this point. Maybe a little later you'll learn where the lone pair might have gone. There's another dude. Crap. But so nitrogen still needs its octets. So with this method, the way we make give the central atom its octet and still not add or remove from our valence count, because we still only have 24 electrons to work with and we've used them all up. The way we show, or the way we give nitrogen its octet is we take a lone pair from one of our outer atoms and we convert it to a shared pair. Now at this point, all 3 outer atoms are the same, so it doesn't really matter. Later on, we talk about major structures in another video, which I will not be playing multiplayer video. We'll see an example where that's not the case. But for now, you got 3 of the same atom. Just pull one off any of the 3 and move it into a shared position. So oxygen still has its 8 electrons, but now nitrogen also has 8. And so now everybody has their octets, so everybody's happy. Now let's look at one more. Sure. Let's look at one more. I knew I shouldn't have done that. All those red dots, I knew I shouldn't have done it. Let's look at phosphorus pentachloride. So again, it fits our general formula. So again, we'll assume we can figure out the Lewis structure just like we did the rest. Again, you start with the valence count. Phosphorus is in group 5. It'll contribute 5 valence electrons. Halogens, again, are in group 7. So 7 for each of those 5. And that gives us a total of 40 valence electrons that we have to show in this structure. Next step, like we did in the last 2, was hook everybody together. And we're assuming those chlorines, all 5 of them, are bonded to the phosphorus as a center atom. But just hooking those chlorines up to the central phosphorus, that gives that phosphorus more than, hello, what are you doing? That gives phosphorus more than 8. It gives it 10. But those chlorines have to go somewhere, and again, they usually aren't connected to each other. But phosphorus is an example. This is an example of a compound that has what we call an expanded valence, which basically means it can have more than 8 electrons. And we'll get into the whys maybe some other time, but just in general, if the atomic number for that element is 13 or higher, if it's higher than aluminum on the periodic table, it can have more than 8 if it needs to. Hello. Where am I at? All right, so it's okay for phosphorus to have 10, you son of a bitch. All right, it's okay for phosphorus to have 10 electrons. So we'll just keep doing what we normally do. We have 30 more electrons to add. And again, you add those as lone pairs, starting with the outer atoms. And doing that uses up the remaining 30. If we had any more, we would just put them on the central atom. Because again, as long as the atomic number is higher than 13, it can have more than 8. It can have 10, 12, whatever. So in this case, our outer atoms have their octets. The central atom, it's got more than 8, but that's okay. So it looks like we're done. So even though there were 3 different structures, what am I doing? Even though there are 3 different structures, you know, a neutral molecule, a polyatomic ion, and one that has an exception to the octet rule, as long as they fit the general formula AXN, then you can approach them the same way every time. Every time. Again, you start with the valence count, then you hook the X's to your A, and use up the remaining electrons as lone pairs. Outside first. If you have enough, after giving the outer atoms their octets, and you should have enough to give them their octets, any remaining will go on the central atom. If you don't have enough, like we saw with nitrate, then that's when you would want to start thinking about multiple bonding. You know, take a lone pair from an outer atom and convert it to a shared pair. You know, make it a bond. Is that? Hey, train, choo-choo. So we'll stop there, and that's probably a good idea. So I don't even know if I'm going to put this up. I sucked so badly. What did I end up getting? Oh, I'm 15th. What did I do? I can't see. Yeah, I can live with that. I have done worse, believe it or not. So we will stop there, and just run me over. And I'll see you guys some other time. Ba-dum, bum, ba-dum, bum.